everyone. Welcome to another lesson for Math 2. We are going to be going over something called distance over time graphs because we're slowly going to work our way towards finding the rate of change of lines, which will be, the next lesson, but not for today. So for distance over time graphs, let's go ahead and take a look at an example right here where we have every morning Tom walks along a straight road from his home to a bus stop, a distance of 160 meters. The graph shows his journey on one particular day. So what we're going to do is we're going to take a look at this graph line by line and try to interpret what's going on. So let's look at the first part here. Starting at 0, 0, we notice it goes all the way up to 100. So Tom traveled, based on the y-axis, he traveled 100 meters away from his home in 50 seconds. So we don't know exactly what's going on, but based on the context of the problem and based on the fact that he's going away from home, in those 50 seconds, maybe he's going to the bus. So this is what I mean. I said we're going to look at each line and just try to interpret what's going on based on the distance he's traveling from home and how quick it's taking him. So then, let's look at this next part right here. Notice how it's going downwards this time? And actually it looks a little bit steeper, right? So we noticed that he traveled 60 meters. And if you're wondering where the 60 came from, because, hey, didn't this go down to 40? Shouldn't he have traveled 40 meters? Well, if you think about it, 100 minus, we start at 100 and we go down to 40. So 100 minus 40 is 60. And he traveled that far in 20 seconds. So don't just look at the endpoints. Think about what is the change from 100 to 40. That would be a reduction of 60 meters. And he's going towards his home now. But aren't you supposed to be going back away from home, Tom? Aren't you supposed to be going away to the bus? So there could be a lot of reasons for why he went back a little bit. I think the best way to interpret it, in my opinion, is that maybe he dropped something on the way to the bus stop and he had to go back and get it. And let's see here. The next part afterwards is this line right here in green. And he's going away from home again. I noticed that he's traveling 120 meters from 40 to 160. That's 120 difference. And that took him from 70 seconds to 100 seconds. That took him 30 seconds. So that's quite a lot of speed. That's quite a lot of distance for quite a short amount of time. So he's probably running to the bus stop now. Maybe he just wants to make sure he gets there on time. Now, we also notice that for the last part, this yellow line, it's a flat line. There's no distance happening. So he must not be moving at all, which kind of makes sense. I mean, he's probably at the bus stop because it says the bus stop is 160 meters away, right? So he's at the 160 mark, and that makes sense. Now, it's important to understand here, guys, that this doesn't represent like Tom going up and down a mountain. In fact, it says Tom is walking along a straight road. This is just how the graph looks like when you're measuring distance over time. This up and down isn't supposed to represent how high above ground he is. It's supposed to represent how fast he's going. And this is the kind of skill that I hope we're going to be working on for the next class. Now, you might have also noticed that all these lines so far have been straight. They have been constant rates of change. So let's quickly talk about some different rates of change, where we have 3 different hoses. And that's right, we're talking about hoses. So there's a cat about to fight a hose. I think the hose is going to win. So it says here, a green hose fills a water barrel at a constant rate. I'm going to put that underline with green, green for green hose. Now, our goal is to figure out which graph represents this situation. If you look at A, B, and C, which one do you think it is? Just think for a moment. If you chose B, you are correct because of the word constant. It is a straight line. That means that rate of change, the amount of water that's going out, never falters going up or down. It's just going in a straight line. Now, if we continue reading this, we read about a black hose, which slowly opened when filling the barrel, and then a blue hose, which is completely open at the beginning and then slowly closed. So we have 2 complete opposites, where it starts off slowly and then it picks up speed. Another one is just gushing out all the water and then it's slowly closed. So looking at the graphs A and C, you can tell that they're obviously completely different beasts, right? And that makes sense. Once again, there are 2 different situations, 2 different graphs. But if you take a look at the black hose, which is slowly opened, look how A right here starts off really shallow and then gets steep. So shouldn't that be our black hose? And then we look at C. Notice how it's super steep and then gets shallow. So that would be our blue hose. And that's really all the skills I want you guys to be able to gain today is just, let's look at these graphs. Can we interpret it based off what the rate of change is doing? And they're going to practice being able to interpret this in a fun activity in class, in our next class. So if you have any questions, feel free to shoot me some emails. Otherwise, make sure you turn in your homework, and you guys have a great day. Bye.